Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2015. So let's get started. First problem, what is the value of this? So what we can see is it's 1 minus 1 plus 25, which is 5 squared, plus 0, so I won't write that. And then that inverse, but this is 0, so this is 25 to the negative first power times 5, which equals 5 over 25, equaling 1 over 5. The answer is C. Number 2, a box contains a collection of triangular and square tiles. There are 25 tiles in the box, containing 84 edges total. How many square tiles are there in the box? Okay, so let's say that there are 8 triangles and b squares. That means a plus b equals 25 because there are 25 tiles in the box, and since it has 84 edges total, it's 3a plus 4b equals 84. And if we multiply this by 3 and then put it under, 3a plus 3b will equal 25 times 3, which is 75, right? And subtracting, we get b equals 9. And since b equals 9, how many square tiles are in the box? The answer is 9. The answer is D. Number 3, Anne made a 3-step staircase using 18 toothpicks as shown in the figure. How many toothpicks does she need to add to complete a 5-step staircase? So since it's just a 5-step staircase, then it's a simple job to just add more steps to make a 5-step staircase. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 times 2 toothpicks because we have 11 of these kind of like L shapes. So the answer is 22. It's D. Number 4, Pablo, Sophia, and Mia got some candy eggs at a party. Pablo had 3 times as many eggs as Sophia, and Sophia had twice as many eggs as Mia. Pablo decides to give some of his eggs to Sophia and Mia so that all 3 will have the same number of eggs. What fraction of his eggs should Pablo give to Sophia? Okay, so for these conditions, Sophia had twice as many eggs as Mia, so if Mia had 1, Sophia had 2. And if Sophia had 2, then Pablo had 6, right? Then that means there was a total of 9, right? And for all 3 to have the same number of eggs, then each has to have 3, right? So Pablo has to give 1 to Sophia and 2 to Mia. What fraction of his eggs should Pablo give to Sophia? So it's 1 over 6. The answer is B. Problem number 5. Mr. Patrick teaches math to 15 students. He was grading tests and found that when he graded everyone's tests except Peyton's, the average grade for the class was 80. After he graded Peyton's test, the test average became 81. What was Peyton's score on the test? Okay, so first of all, 80. This is when he graded everyone's test except Peyton's, so that's for 14 students. 14 students. That means the average is 80, right? But then after he graded Peyton's test, the test average became 81, right? So that's when he graded 15 students. The average became 81, right? But then let's just say that 15 students was graded. So Peyton's was graded and it was still 80, right? So if this happened, then this means Peyton's score is 80, right? But then since Peyton alone, since Peyton alone raised the average of everybody by 1, that means Peyton's score must be 80 plus 15 times the increase. So 15 times 1. 15 times 1. 15 times 1. And so this is 80 plus 15, which is 95. So the answer is E. Number 6, the sum of 2 positive numbers is 5 times their difference. What is the ratio of the larger number to the smaller number? Okay, so let's say that these numbers are A and B. So the sum of 2 positive numbers is 5 times their difference. And let's say A is greater than B, so that way this will be a positive number. And this will also be a positive number, right? And so A plus B equals 5A minus 5B. A plus B equals 5A minus 5B, so 6B equals 4A. Where's the ratio of the larger number to the smaller number? So since A is larger, what we are looking for is A over B. This is if B comes over here and 4 goes over there. That means A over B equals 6 over 4, 3 over 2. So the answer is B. Problem number 7. How many terms are there in the arithmetic sequence 13, 16, 19, all the way to 70 and 73? Okay, so first of all, we are dealing with the number of terms, right? So we don't care if we subtract the same amount from all of these things, right? So let's subtract 10 from everything. So that would be 3, 6, 9, all the way to 63, right? And now let's divide by 3, because that would also keep the number of terms constant. 1, 2, 3, all the way to 21. That would give us easily 21 terms. The answer is B. Number 8. 2 years ago, Pete was 3 times as old as his cousin Claire. 2 years before that, Pete was 4 times as old as Claire. In how many years will the ratio of their ages be 2 to 1? Okay, so 2 years ago, so Pete minus 2 was 3 times as old as his cousin Claire. So Claire 2 years ago. And 2 years before that, so it's P minus 4. This is 4 times as old as Claire, 4C minus 4. And so this gives us P equals 3C minus 6 plus 2, so it's minus 4. And this gives us P equals 4C minus 12, right? Because this is minus 16 plus 4. And so we know that 3C minus 4 equals 4C equals 4C plus 4C minus 12, so C equals 8. C equals 8, and that will give us, so for the ratio of their ages to be 2 to 1, C is 8 now, and so Claire is 8 years old now, and Pete is, if we put 8 into here, that would give us 3 times 8 minus 4, so P is 20 years old. And so for the ratio of their ages to be 2 to 1, that means Claire's age equals the difference between Pete minus Claire, right? But this difference will always stay constant, right? And so this difference is, let's do this in different color. Difference is 20 minus 8, which is 12 years. And so for this to happen, Claire has to be 12 years old. And since Claire is 8 now, that will happen in 4 years. The answer is 4, it's B. Number 9. 2 right circular cylinders have the same volume. The radius of the second cylinder is 10% more than the radius of the first. What is the relationship between the heights of the 2 cylinders? Okay, so we have 2 cylinders, but the radius of the second is 10% more. So the first will be a little bit higher, and the second will higher, and the second will be a little bit lower and a little bit bigger, like that, right? And so since the radius of the second is 10% more, then let's just say that the radius of the first is 10 and the radius of the second is 11. That way this condition is satisfied. What is the relationship between the heights of the 2 cylinders? Okay, so for this we need to use the fact that they have the same volume, right? And so if this is H and this is big H, that means big H times 10 squared pi, so 100 pi, equals small h times 121, so because that's 11 squared, and pi, right? And so that means that big H over small h equals 121 over 100, because if we take out pi from both sides, divide pi from both sides, and then move 100 under here and move h under here, then that would give us that big H over small h equals 121 over 100, right? And so that's what we have here. And so this means that this is the first height. So the first height is 21% more than the second. The first height is 21% more than the second. The answer is D. Number 10. How many rearrangements of A, B, C, D are there in which no 2 adjacent letters are also adjacent letters in the alphabet? For example, no such rearrangement could include either A, B, or B, A. Okay, so A, B, C, D are here. But then we can see that this means that B cannot be with A or C, right? And so B must be connected with D and only D. And for the same reason, C must be connected with A and only A. That means B and C must be at the edges, right? So B something something C. And since B must be connected to D sits here. Since C must be connected to A sits here. And we also have to consider the time where we turn this around, where we turn this around entirely, right? So like C, A, D, B, that would be just reversing the whole thing. And so we have CADB and BDAC. That means we have two rearrangements. The answer is C. Number 11. The ratio of the length to the width of a rectangle is 4 to 3. If the rectangle has diagonal of length d, then the area may be expressed as kd squared for some constant k. What is k? Okay, so we have a rectangle like this, and the length to the width is 4 to 3. And the rectangle has a diagonal of length d. Oh, okay, so since we don't know the actual length and the width, let's say it's 4a and 3a, right? Then since it's a rectangle, so this is a right angle, so if we draw a diagonal, then that length would be 5a due to the Pythagorean theorem. And so d would equal 5a, right? And so the area may be expressed as kd squared. So area of the rectangle, this is obviously 3a times 4a, which is 12a squared, right? But then we want to make it as kd squared. So since d is 5a, we can just plug that in there. So it's k times 5a squared. This is 25k times a squared. So since 12a squared equals 25k a squared, k equals 12 over 25. So the answer is C. Number 12. Points root pi comma a and root pi comma b are distinct points on the graph of y squared equals this, right? So what is the absolute value of a minus b? Okay, so first we want to plug this into this equation, because then the y values that come out here, those would be a and b, right? And so y squared equals pi squared, y squared plus pi squared equals 2 pi y plus 1, right? So y squared minus 2 pi y plus pi squared equals 1. Y minus pi squared equals 1, right? And so y, and so that gives us that y, I'll move this whole thing over to the left. Y equals 1 plus pi or minus 1 plus pi, right? Because then that way this would be either 1 or minus 1. And so the absolute value of a minus b, so one of these is a and the other is b. So the absolute value of this is, let's say that this is a and this is b. 1 plus pi minus 1 plus pi. The absolute value of this will be the absolute value of 2, so the answer is 2. It's C. Number 13. Claudia has 12 coins, each of which is a 5-cent coin or a 10-cent coin. There are exactly 17 different values that can be obtained as combinations of one or more of her coins. How many 10-cent coins does Claudia have? Okay, so with 5-cent coins and 10-cent coins, the minimum value that can be obtained is just 5 cents, right? But then since there are 17 different values and both of these are a multiple of 5, that means the highest value, so this means the highest value obtainable is 17 times 5. So the answer is, 17 times 5 is 85, right? And so let's say Claudia has A 5-cent coins and B 10-cent coins. And then that would give us A plus B equals 12, because she has 12 coins in total, and 5A plus 10B would equal 85, because if 85 is the highest value, that means Claudia combined all of her coins to get that value, right? And so if we divide this by 5, then that means A plus 2B equals 17. And if we subtract this from that, if we subtract it, that gives us B equals 5. And B equals 5, so 10-cent coins, the number is B. The answer is 5. It's C. Problem number 14. The diagram below shows the circular face of a clock with radius 20 centimeters and a circular disc with radius 10 centimeters externally tangent to the clock face at 12 o'clock. The disc has an arrow painted on it, initially pointing in the upward vertical direction. like this, right? Let the disk roll counterclockwise, let the disk roll clockwise around the clock face. At one point on the clock face, will the disk be tangent when the arrow is next pointing in the upwards vertical direction? Okay, so we see that the clock's radius is 20 centimeters, so this is 20 centimeters, and the disk's radius is 10 centimeters, right, like this. And so since it's and since this radius is 1/2 of the clock, that means one full circumference of the disk is going to be 1/2 of the circumference of the clock, right? And so if we turn the disk one whole round, right, then that will just make it come here, right, at the halfway point. And since let's say this point is where it was being tangent, and that point will be at that same point, right, because yeah, so that same point will be tangent, right, because it's made one full revolution. And so seeing that, we see that the arrow is pointing downwards here. The arrow is pointing downwards like so, right? And so let's see, from so to get from this upward pointing arrow to this downward pointing arrow, we see that the arrow of the disc has gone through like multiple phases, kind of. And so first it started off pointing upwards, but then it rolled clockwise, right? And so the disc would have gone like this, right? And so after this, it would have went like that, and then it would have pointed down, and then it would have pointed like that, and then it would have pointed back up again, and it would have pointed right, before finally becoming this downwards arrow, right? And so we can see that there are 5 of these kinds of phases that the disk had gone through, right? But then we see that there are also 5 kind of points on the clock face that are equidistant, and and also all of these have the same time between them to complete, right? Because it's all 90-degree rotations. And so we see that each of these points on the and so each of those points on the clock face, that is equal to each kind of state that this is in, right? And so the arrow will be like this at 1 o'clock, like this at 2 o'clock, like this at 3 o'clock, this at 4 o'clock, and this at 5 o'clock, right? But we are asked, at one point will the disk be tangent when the arrow is next pointing the upwards vertical direction. So we want this one, and this one is connected to 4 o'clock. So the answer is 4 o'clock. It's C. Number 15. Consider the set of all fractions x over y where x and y are relatively prime positive integers. How many of these fractions have the property that if both numerator and denominator are increased by 1, the value of the fraction is increased by 10%? Okay, so if both numerator and denominator are increased by 1, so x plus 1 over y plus 1. That and then the value will be increased by 10%. This is 11x over 10y, right? And so yes, because this is 11 over 10 over x over y, no, multiplied by x over y, right? And so cross multiplying, that will give us that 10y times x plus 1 equals 11x times y plus 1. And so 10xy plus 10y equals 11xy plus 11x. So xy plus 11x minus 10y equals 0, and x plus 11 x minus 10, y plus 11. This equals negative 110, right? And so yes, just to check, x and then minus 10y plus 11x, and then that will give us negative 110. And so let's now put this up like that. And so how many of these fractions have this property? Okay, so what fraction, so what values can x and y take? And x and y have to be relatively prime positive integers, right? And so x can be negative 1, and this can be 110. This x can be negative 2, and y plus 11 can be 55. Or x can be negative 5, and y can be 22, and x can be negative. No, actually x can't be negative 10 because then x will be 0, right? So yeah, so okay, these are all the x minus 10 and y plus 11 values that we have. And so this gives us that x equals 10 minus 1, so it's 9. Y equals 110 minus 11, so that would be 99. This gives us that x equals 10 minus 2, which is 8. Y equals 55 minus 11, which is 44. And this gives us that x equals 10 minus 5, which is 5. And y gives us 22 minus 11, which is 11. But then, see, let's see this again. They have to be relatively prime positive integers. X and y, 9 and 99, they are not relatively prime, so this is out. 8 and 44 are also not relatively prime, so this is out. But 5 and 11 are relatively prime, so this is an answer. How many of these fractions? We only have one set of x and y values, so the answer is B. Number 16, if y plus 4 equals x minus 2 squared and x plus 4 equals y minus 2 squared and x is not y, what is the value of x squared plus y squared? Okay, so let's just expand all of these. Y plus 4 equals x squared minus 4x plus 4, and we can take out the plus 4's, like that. And so that will be y equals x squared minus 4x, and we could do the same thing again for this one, but then as you can see, this equation is just x and y swapped from this one, so we can just swap x and y's here too. X equals y squared minus 4y, and if you actually expand this, this is what you get. And so first of all, we want the value of x squared plus y squared, right? And so let's put this up in a corner like that. And then first we need the value of x squared plus y squared, so we try to add these up. Add the two equations. Then that gives us x squared minus 4x plus y squared minus 4y equals x plus y. And so x squared plus y squared equals 5x plus 5y, which is 5 times x plus y, right? And so we get from this that x squared plus y squared equals 5 times x plus y. And so now all we need is x plus y. And so to get x plus y, what we do is, since we've added this before, now we have to subtract them, right? And so what we get is y minus x equals x squared minus y squared minus 4x minus, so it's plus 4y. And so that gives us minus x minus y equals x plus y, x minus y, and then minus 4x times minus 4 times x minus y, right? And so we can divide by x minus y because they're not 0. It said x is not y. And so negative 1 equals x plus y minus 4. And so this can go over. That will make it plus 4, right? And so x plus y equals 3. And since x plus y equals 3, since we have this, we can put this inside x plus y. So this is 5 times 3. This is 15. So the answer is 15. It's B. Number 17, a line that passes through the origin intersects both the line x equals 1 and the line y equals 1 plus root 3 over 3x. The three lines create an equilateral triangle. What is the perimeter of the triangle? Okay, so let's draw a coordinate plane really quickly, like that and like that, right? And so we have the line x equals 1. X equals 1 like that. And the line y equals 1 plus root 3 over 3x, and this is less, and that's between 1 and 0, so that will be kind of like this, right? Yeah, so the y-intercept is 1, and this would be like that, and so that would be 1 plus root 3 over 3x, and a line that passes through the origin. So the last line has to pass through the origin and intersect both of these and create an equilateral triangle. Oh yeah, okay, so first let's look at this. It's 1 plus root 3 over 3x, and so that means the ratio of this line to this line, this is 3 to root 3. which is basically root 3 to 1, right? And so this is 1, so this is a 2 to 1 to root 3. That means it's a 30, 69 triangle. So that means this is 60 degrees, right? And so to have a line that passes through the origin and make this making this an equilateral triangle, that will be something like this, right? Something like this. And for that, and also this will have to also be 60 degrees, right? And so this is the line that passes through the origin. So this is our last line. But then for this, since because of that, we can get the what is it? We can actually we don't have to get the slope, because what we want is the perimeter of the triangle, right? And so if we know this perimeter, that line, then we have our answer, right? Okay, so since this is 1, this is also 1, right? And this is also 1 because this should be a square, right? And so this is yes, so this is x equals 1, so this is 1, and this is root 3 over 3, so this much is root 3 over 3, right? And since we can see that this green triangle and this green triangle, they are congruent, so that means that this length is root 3 over 3 also. So we have our one side length, so this side length we know now, it's root 3 over 3 plus 1 plus root 3 over 3, which is 3 plus 2 root 3 over 3. And that's just one side, right? But we want the whole perimeter of the triangle, so we have to multiply that by 3. So 3 plus 2 root 3 over 3 multiplied by 3 equals, these to cancel out, and 3 plus 2 root 3. So the answer is D. Number 18. Hexadecimal, which is base 16 numbers, are written using numeric digits 0 through 9 as well as the letters A through F to represent 10 through 15. Among the first 1,000 positive integers, there are n whose hexadecimal representation contains only numeric digits. What is the sum of the digits of n? Okay, so we have base 16 numbers, and first we have to find out, since this is base 16, its digits will go like will be like something times 16 to the 0th power, something times 16 to the 1st power, something times 16 to the 2nd power, something times 16 to the 3rd power, right? And so first we need to figure out what 1000 would be in base 16, because that would set our kind of upper bound, right? And so first let's see, can 1000 be 16 cubed? Yeah, so is 1000 greater than or equal to 16 cubed? First 16 cubed, this is 2 to the 4th power cubed, this is 2 to the 12th power, but we know that 2 to the 10th power is 1024, and that's already greater than 1000, so obviously this will be less than so obviously that will be greater than 1000, so 1000 what you would get here. And what about 16 squared? 16 squared, that will be 16 squared, so 2 to the 4th power to the 2nd power, so that's 2 to the 8th power, which is 256, right? And so how much of 256 can 1000 endure before 256 times something goes over 1000? So 4 seems okay. 256 times 4, this is 1024, and so that will so 4 won't be in there. Let's try 3. 256 times 3. This is 768, so that's obviously less than 1000. So 3 can be in the and so 3 can be in the third in the first digit, right? And so we have 3 digits, and the first digit can be maximum of 3, so it can be either 0, 1, 2, or 3, right? And so whether there are 0, 1, 2, 3 numbers, we can have digits from 0 through 9 here and 0 through 9 here, as well as 0 through 9 here and 0 through 9 here, for every value, right? and we don't need to worry about it going over 1000 because it's because the because hexadecimals are base 16, so this will do kind of very little, and so this will be the deciding factor, right? And so anyways, so this gives us 10 possibilities for every 0 to 9, and so this means we have 4 times 100, 4 times 10 squared, because we have 10 2 times 4 each, right? So we have 4 times 10 squared equals 400 possibilities. So this might be n, but actually this is not n, because we have forgotten that in here we have included 0, 0, 0. So that would make it 0. So that would make it 0. And it says it needs to be first 1000 positive integers. So we have to subtract that from here. So we have to do 400 minus 1, which is 399. So the answer is 3 plus 9. 3 plus 9 plus 9, which is, what is it? 18 plus 3, it's 21. So the answer is E. Number 19. The isosceles right triangle ABC has right angle at C and area 12.5. The rays trisecting ACB intersect AB at D and E. What is the area of CDE? Okay, so we have the isosceles right triangle right here. And as you can see, it has a right angle at C. And area would be 12.5, and so since area is 12.5, that means the whole square would have had area of 25, right? And so that means each leg of the right triangle, that is root 25, which is 5. So this is 5 and this is 5. And the rays trisecting ACB, so since ACB is trisected, this means that this is 30 degrees, this is 30 degrees, and this is 30 degrees. Those intersect AB at D and D, so those are here. What is the area of CDEs? Okay, so we want this area, right? So first thing that we can do is we can put a line from E to right here, and so and since this is an isosceles right triangle, this is obviously 45 degrees from the start, and if we make it so that it's like right triangle, then we can see that this is 45 degrees and this is 60 degrees, right? And so this triangle right here, that will be a 30, 60, 90 triangle, while this would be that would be an isosceles right triangle, right? And so to get CDE, we have to have ACB and subtract CEB and ACD from that. And since we can just see by plain sight that ADC and CEB is congruent, so they have the same area, then all we need to know is this height, right? Because that height will give us the area of CEB. So let's set this height as A. Let's say this is A. All right, then since this is that's an isosceles right triangle, this would be A, and since this is 30, 60, 90, this would be 2A, and this would be root 3A. That will be root 3A, right? But then we see that the whole length is 5, so 5 equals root 3A plus A. A equals 5 over root 3 plus 1, because this is A times root 3 plus 1, so just divide by root 3 plus 1. And so this equals all over 2, and 5 times root 3 minus 1, right? Okay, and so A is this. And so now what we have to do is we have to do A times BC, A times BC, which is 5, times 1/2 will be CEB, and to get ADC also, then we have to multiply by 2, because that will be the combined area of ADC and CEB. So this is just 5A. So that's just 5A. And to get CDE, then we have to do the whole area minus that, right? So the whole area is 12.5. 12.5 minus 5A. This is the area of CDE. And so let's just move 12.5 to say it's 25 over 2 and 5 and negative 5A. That can just become minus 5 times this times 5, minus 5 times that, right? So it's 5. No, I'll just move this here, right? And erase this. So this would equal all over 2, and 25 minus 5 times 5, so 25 times root 3 minus 1. And so this is 25 minus 25 root 3 plus 25 all over 2. This is 50 minus 25 root 3 over 2. So the answer is D. Number 20. A rectangle with positive integer side lengths in centimeters has area A square centimeters and perimeter P centimeters. Which of the following numbers cannot equal A plus P? Okay, so let's say that the side length is x and y centimeters. So it's x by y centimeters. And so its area A would be xy, and perimeter would be 2x plus 2y, right? And so which of the following numbers cannot equal A plus P? A plus P, this equals this to add it together. So it's xy plus 2x plus 2y, right? And so this is x plus 2, y plus 2, and since this has a leftover 4, we have to subtract 4. That's A plus P. And if we add 4 to both sides, that gives us 4. 4 plus A plus P equals x plus 2 times y plus 2, right? So yeah, so that's what we have. And as you can see, all these so the answer choices are A plus P values, right? They are possible A plus P values, but we have an equation for 4 plus A plus P, right? And so A plus P plus 4 values, those would be 104, 106, 108, 110, and 112, right? And so we have to find a value for which x or y is impossible, right, for these numbers, right? And so let's see if 104 can be x plus 2, y plus 2, right, when x and y is positive integers, right? And so x and y have to be positive integers. And so 104, this is 2 times 52, so it's 4 times what is it, 26, and so obviously it's possible, right? And so 104 is not the answer. If it's 106, this is 2 times 53, and 53 is a prime number, so this is all the factorization that it can do, right? And so this is its like most factorized point, but still that means either x or y is 0, and so this cannot be possible, so the answer is B. Problem number 21. Tetrahedron ABCD has AB equals 5, AC equals 3, BC equals 4, BD equals 4, AD equals 3, and CD equals 12 root 2 over 5. What is the volume of the tetrahedron? Okay, so let's first draw this out. AB, like this, is 5, and C and D would be like this. So like that, with CD in the background, right? And so AB would be 5, AC is 3, BC is 4, BD is 4, AD is 3, and CD equals 12 over 5 and then times root 2, right? And so from these side length ratios, we can see that ADB is a right angle and ACB is also a right angle. And now we have to get the volume of the tetrahedron, right? And so for better visualization, I will make a different diagram like that, right? And so AB is also so right now AB is in the background, so this will be 5, and AC is 3, B is 4, same things like this. But now CD is at the foreground, right? And so from this we can kind of like draw like a perpendicular line to be A, and from C to that same point, and we can see that it is a right angle, right? Yeah, so we can know that that is a right angle because CD is 12 over 5 root 2, right? So if we zoom in, CD is 12 over 5 and then root 2, right? And if this is D, would be like right angle to there, and so that would mean that this is 4, 3. So this length would be 4 times 3 over 5. So this is 12 over 5, right? And so we can say that this red length is 12 over 5, and same for here because BDA and BCA are the same. So this is also 12 over 5, right? And then if you see, the ratio of the length is 1 to 1 to root 2. And so that means that it's an isosceles right triangle, right? And so what we wanted is the volume, right? And the volume is so since now we have established that this is indeed a right angle, if BCA, if this is the base, right, then this will be the height of the that will be the height of the tetrahedron. And so BCA, the area is 4 times 3 times 1/2. This is 6, right? And this height is 12 over 5, so it's area times height times 1/3 because it's a tetrahedron. And so that will give us 2 times 12 over 5. This is 24 over 5, so the answer is C. Number 22. 8 people are sitting around a circular table, each holding a fair coin. All 8 people flip their coins, and those who flip heads stand, while those who flip tails remain seated. What is the probability that no 2 adjacent people will stand? Okay, so we have a circular table like that, and we have 8 people sitting around it. 1, 2, 3, 4, 5, 6, 7, 8, right? And all 8 people flip their coins. Okay, so the maximum amount of people for people who flip their coins and those who got heads, and for all of them to not be adjacent, that is maximum is 4, because this would be the possible arrangement at 4, and if there's 5, then the 5th would have to be one of these 4 people, and that would not meet the condition that no 2 adjacent people should stand, right? So we can have 0 people stand, 1 person stand, 2 or 3 or 4 people stand. And first of all, if 0 people stand, it's very easy. It's just 1 possibility. And if 1 person stands, that's also very easy. It's just choosing 1 out of the 8. So that's 8 possibilities. And choosing 2, and choosing 2 is, first we pick 1 person out of the 8, so that's 8. And so let's say we picked this person, right? Then this person and this person can't get heads, so it should be one of the 5 people who can get heads, right? So it's 8 times 5. And so let's say that this person got first heads, and then this person was chosen as the second heads. But then what happens if this guy gets first heads and this guy gets second heads, right? Then that would just be the same thing, right? But then it's counted as difference in here, so we have to divide by 1/2. So we have to multiply 1/2 to it, and for 3 people to and for 3 people to stand, then we can have a configuration like this. So with 1, 1, and 3 people as gaps, or we can have this configuration with 2, 2, and 1 person as gaps, right? And there are no other configurations that can satisfy the that can have 3 people stand while meeting these conditions, right? But then if you see, the number of such right triangles, the number of these right triangles, they are 8, because they are because the person who is at the center can be any one of these 8 people, right? So that's why it's 8 possibilities. And next, for this one, this is also very similar, because the number of possibilities for that to happen is also 8, and also because the person at the very top can be any of these 8 people. So that's 8 plus 8, right? So this So that's 8 plus 8. And now, moving on to what if there's 4 people who stand? So 4 is the maximum number of people that can stand, right? And so there is just 2 ways to do it. These 4 can stand, or these 4 can stand. So that's the only 2 ways to do it. So that's also easy too. And so if we if we calculate this, then these gives us 9. 1 plus 8 is 9. And since this is 4 times 5, so it's 20. And this is 16. This is 2. So this gives 18. This gives 38. And this gives 47. Right? So we have 47 total possible number of total possibilities, right? But then it asks for the probability that no 2 adjacent people will stand, and we have 8 people and they're holding a fair coin. So the total number of possible outcomes is 2 to the 8th power, which is 256, right? And so our probability will be 47, this 47 over 256, and that answer is found at A. The answer is A. Number 23. The zeros of the function fx equals x squared minus ax plus 2a are integers. What is the sum of the possible values of a? Okay, so let's say that the zeros are m and n. Okay, and so that would give us that m plus n equals a and mn equals 2a, right? And so since a is m plus n, 2a equals 2 times m plus n. And so mn equals 2 times m plus n. So mn minus 2m minus 2n equals 0. m minus 2, n minus 2 equals 4, right? And so let's say that m is greater than n. No, greater than or equal to n, right? Because that way n and m could get mixed up and nobody will notice, right? And so for the possibilities for that, they are integers, right? So they can't be like fractions or decimals or anything. First probability is these could be 4 and 1, or 2 and 2, or minus 1 and 4, no, minus 1 and minus 4, or minus 2 and minus 2, right? And so these are all plausible possibilities, and for 1 will give m equals 6 and n equals 3. This will give m equals 4, n equals 4. This will give m equals 1 and n equals negative 2. This would give m equals 0 and n equals 0. And so what was a? A was m plus n, right? And so if we move this whole thing to the left, then that will give us a values. A is 9. A is 8 in this case. 8 is negative 1. And here a is 0. Right? And so if we add all of this together, it's 9 plus 8 minus 1. The answer is 16. So the answer is C. Number 24. For some positive integers p, there is a quadrilateral ABCD with positive integer side length, perimeter p, right angles at b and c, AB equals 2, and CD equals AD. How many different values of p is less than 2015 are possible? So let's draw a diagram first. So this would be what ABCD looks like, right? And here CD equals AD, so these two are the same, and AB equals 2. And let's say this is B, no, right? AB equals 2. And I want to put a line down like that, right? That will make it a right angle, and so this would also be 2. Let's say this point is E, right? And so CE would be 2. And if ED is A, then AD would be A plus 2, right? Because CD equals AD. And BC would be same as AE, right? But then AE, we can get this with the Pythagorean theorem because this is a right triangle. And so BC is square root of A plus 2 squared minus A squared equals root 4A plus 4, right? So this is 2 root a plus 1, right? And so this is 2 root a plus 1. And what we want to do is we want to change root a plus 1 into something into like a normal variable, because roots are very tiring to work with. So let's just say that root a root a plus 1 is x, right? And so that would make this 2x. And since root a plus 1 is x, a equals x squared minus 1. So a equals x squared minus 1. And a plus 2 would equal x squared plus 1. X squared plus 1, right? And so how many different values of p is less than 2015 are possible? So p would be x squared plus 1, and then x squared plus 1 again for CD, plus 2x plus 2. So this is equal to 2x squared plus 2x plus 4, right? And so this has to be less than 2015. And so 2x squared plus 2x is less than 2011. X squared plus x is less than 1005.5, right? And so this is x times x plus 1, right? And we know that 32 squared equals 1024, right? And so what if x plus 1 equals 32? Then x will be 31, right? And so 31 times 32, this let's do this in a different color. 31 times 32, this is 32. This is 32 times 32 minus 32. So this is 1024 minus 32, which is less than 1000, right? And so if this so if x was 31 and x plus 1 is 32, then that would be the maximum x value, right? Because if x was 32, then that would be 32 times 32. No, then that would be 32 times 33, which is even greater than 1024, so that won't make it. And so our maximum x value is 31, and so we can have x values from 1 all the way to 31. So we have 31 x values. The answer is B. Our last problem number 25. Let S be a square of side length 1. 2 points are chosen at random on the sides of S. The probability that the straight line distance between the points is at least 1/2 is a minus b pi over c, where a, b, and c are positive integers with GCD a, b, c equals 1. What is a plus b plus c? Okay, so we have a square of side length 1. That will be S. And 2 points are chosen at random. Okay, so since we're choosing 2 points and it's a square, that then it means that it doesn't matter which point one of the points is in. So we can fix one of the points to S, to one side of S, right? And the other points can go here, or it can go here, or it can go here, right? And so we can divide this into 3 possibilities, right? So if we make 2 more copies of this, one like that and one like that, right? And so we have three kinds. So we have 3 possibilities where the other point is next, where the other point is on the same side, or on the opposite side, or on an adjacent side, right? Because this is equal to this, right? So it's just the same thing as an adjacent side. And so first, let's try to solve the probability for them being on the same side. And so for here, let's call the red one x and the blue one y. So this is y, and the red one would be x, right? And so since the distance between since the distance between the points has to be at least 1/2, right? And so if we kind of plotted x and y, x can go from 0 to 1, and y can go from 0 to 1. So if x is 0, y can go anywhere from 1/2 to 1, right? Because their distance has to be at least 1/2. And as x as x increases, like this, as x increases, right, then the then the possible y also has to increase like this, right? And so when x is 1/2, when when x is 1/2, then that means there is only this point, that point at the far end for y to go. But then when x becomes greater than 1/2, then y can be then y can be below x, right? And so y can come here, and as x increases, so when x equals 1, y can be anywhere from 0 to 1/2, right? And so doing just as we did before, this much would be the possible range of y, right? And so since the whole thing is 1 and the shaded amount is 1/4, so the probability for this so the probability for the distance to be at least 1/2 would be 1/4 for this one. So that would be 1/4, and then multiplied by the probability that this will occur at all. So that's 1/4, right? Because x can go anywhere from here, and it chose this one, so it's 1 out of 4. And and x times y, and if x and y are on opposite sides, and so their minimum distance is actually 1, right? So their minimum distance is 1. So that means that they will always be at least 1/2 apart, right? So they will always be at least 1 apart. So that also means it will also be at least 1/2 apart. And so so the probability for this being so the probability for the distance being at least 1/2 is obviously 1, because it will always be that way. And next is multiplied by the probability that x will come on the opposite side at all. So it's 1/4. And lastly, when x is adjacent to y. Okay, so in this case, let's first get the probability that x would be adjacent to y. So it's 2 possibilities out of 4. So it's 2/4, which is 1/2, and then we have to multiply that by the by the probability that x and y will be at least 1/2 apart, right? And so let's make kind of like a graph similar to what we did in the first part. So if we make a graph like x and y, and x can be maximum 1 and y can be maximum 1, right? And so what we notice is if y is at the halfway point, then x can become anywhere from 0 to 1, right? Because this length is 1/2, right? So no, actually, let's talk about it in terms of x. If x is at the halfway, okay, so if x is at the halfway point or further than that, so if x is anywhere from here to here, then y can be anywhere from 0 to 1, right? And so if x is anywhere from 1/2 to 1, y can be anywhere from 0 to 1. So this whole thing is shaded in, right? And same thing when y is from 1/2 to 1, going from 1/2 to 1, then x can be anywhere from 0 to 1 also, by the same principle. So like that, and so this must also become shaded, right? And so for this part now, what happens if both x and y are so what happens if both x and y are within 1/2? So let's zoom in. And so if y is 1/2 and x is at 0, that is a possibility, right? Because that would mean this distance is 1/2, right? But then what could happen is y can move up. So if y moves up, then the 1/2 distance would become something like this, and so x would have to be from here to here, right? And so yes, and if y comes even closer, then that length would be like this, and if y comes even close, and if y comes even closer, then that length would be like this, and so on. And so if we do and then so if we put it like this, the distance can be either like this 1/2, and it can be anything from, sorry, that should be a straight line from here to right there, right? And so this is what it should be, right? And so if you see, it looks like a square minus a quarter circle, right? And it actually is a square minus a quarter circle. And so that would be right here, the square minus quarter circle. And so this will have to be shaded in. And so now let's calculate this area. That would be first, the black area is 3/4, so it's 3/4 plus, and then this blue area, that would be 1/4 minus 1/4 times 1/2 squared pi. 1/2 squared pi, right? And so this much is 1, and it's minus 1/16 pi. 1/16 pi. And so this becomes 1 minus 1/16 pi. So it's pi/16, right? And so that's all we needed to get. So that's all we needed to get. And now we all just have to add these three together. And so if we do that, then this will be 1/16, this will be 1/4, and this will be 1/2 minus pi/32, right? And so if we add these up together, then it's all going to be over 32, and 2/32 plus 8/32, that's 1/4, plus 16/32, that's 1/2, minus pi/32. So this is, what is it, 26 minus pi/32. So A, B, and C are 26, 1, and 32. So 26 plus 1 plus 32, this equals, how much is that? 59. So the answer is 59. It's A. So that was the end for the AMC 10A from the year 2015, and thank you for watching.